Right. Hello, everyone, and welcome to Traffic Corner Tuesday. My name is Nancy Crow, and I'm the Vice President of Marketing at SPAC Consulting, and I'll be your host for today's session. I want to start by letting everybody know that today's webinar you can listen to on any of your devices. It does not require a dial-in number, which means that we should be able to have all of our audience members hear our presentation regardless of where you are. Also, please join the conversation. Feel free to ask questions, share your experience. Just use the chat button on the side, and I will be helping to guide some of those questions over to today's presenters. All right, and then finally, I want to share with everybody that today's presentation is brought to you by SPAC Enterprise. SPAC Enterprise consists of a group of 6 traffic engineering companies focused on providing products and services that improve transportation globally. Our companies provide traffic study consulting services, traffic data collection products and services, and free trip generation data. Learn more by visiting any of our websites or by visiting Mike on Traffic. Today's topic is exploring alternative intersections, and we've also updated the next 2 upcoming Traffic Corner Tuesdays. A quick note to all of our attendees that April's session, we've had a date change. It is going to be on April 24th, and it will be on unwarranted stop sign research. This is a new research that our SPAC consulting team has completed, and we're excited to share our findings. Finally, I'd like to introduce our presenters for today. Mike Spack is the president of SPAC Consulting and is the recognized authority on traffic studies. He is a graduate of the University of Minnesota, past president of the North Central section of Institute of Transportation Engineers, and a fellow of the Institute of Transportation Engineers. Since 1996, Mike has led over 1,000 traffic engineering projects, and during the past 2 decades, Mike has founded 4 companies, including SPAC Consulting. He is also the creative force and principal writer on the industry-leading blog, Mike on Traffic. Also joining us today is Bryant Fiesick. Bryant is vice president of SPAC Consulting and is also widely known in the transportation industry. He's managed more than 1,000 traffic engineering projects, and he is also a graduate of the University of Minnesota and an expert in Synchro, SimTraffic, vStro, and vSim traffic modeling software packages. Please join me in welcoming Mike and Bryant to today's session.
Thanks, Nancy. All right, thank you. So as Nancy opened up with, we will be talking about alternative intersections today, and a clarification. We're going to focus on intersections, at grade intersections, and not get into freeway interchange design. A lot of the concepts are similar, but that can spin in many different directions.
And we should also clarify that we will be touching on different ones, but in a half-hour webinar, obviously we can't go into a ton of detail. So
yes,
we'll try to hit a bunch of things. We'll try to introduce few different topics, but this is not the end all be all for alternative intersections. So with that.
Okay, so starting out, we have an aerial here with a bunch of intersections that are not alternative intersections. So kind of what we consider normal intersections are squared up, 3-legged or 4-legged intersections with stop signs or signals controlling them. So that's
traditional intersections. Everybody should be familiar with these.
Yes, and these are more than 95%. I'm making up statistics, but the vast majority of intersections out there. So when we're talking about alternative intersections, we're talking a very, very tiny percentage of the intersections out there. But from a traffic engineering standpoint, they're some of the most fun things to work on, because definitely. We get to apply our creative problem solving to them.
All right, so then if we start with that backdrop of what we know is not an alternative intersection, then the question becomes, why would you use an alternative intersection? So what is driving you to another option, basically? Why can't you use the traditional?
Yeah, and really there's just a bunch of scenarios on criteria and situations you'll run into where a normal intersection isn't going to quite perform the way you'd like it to. And the first issue is obviously you have a capacity problem. This is the majority of alternative intersections are put in because normal intersections won't operate well.
Yep. Second one kind of feeds into the capacity, but a lack of gaps. So this could be for pedestrians. It could be for turning movements. It could be, again, related to capacity. You don't have enough time for your left turn movement, something like that, or you don't have enough for your side street to get through. Again, specific, you're looking for those specific problems that can't be solved by a traditional intersection.
Yeah, and next is you have safety issues, and for some number of reasons that a typical intersection kind of improvement project, making the intersection bigger or upgrading the traffic control, you just don't think it will solve the safety issues. So you have to start thinking creatively.
Sight distance can be another factor, as you, again, just based on either what's around it, the specific characteristics of your site. As you evaluate the sight distance, there may be a reason to say signal won't work here for this reason.
Yeah, the topography may limit, you may think creatively will save you money.
Yes.
by coming up with an alternative design.
Right along with that is right-of-way that can be limiting. You can't fit the turn lanes in you need. You can't put the signal poles in. There could be various reasons that you have limited right-of-way, and you can't get what you need to put in the traditional. So this leads you towards those creative solutions. What can you do with what you have?
And then the last, which can go in favor of an alternative intersection or lead to you living with a standard intersection that isn't performing as well, but cost obviously overlays everything we do in our industry.
Yes, very much so. So those are the things that we would look at to say you have a specific issue, either with the intersection itself, a particular movement, you're looking at something and you've got the issue. So as we think about the process of how you would get to your preferred alternative, whether it's an alternative or traditional intersection, that process you want to go through is first just defining what is the issue. If you start with the backdrop of you go with your traditional, a signal, stop sign, for whatever reason it won't work, why won't it work? And you need to understand that base issue first, and then you can expand your thoughts as to what will work.
Right. So it typically is some combination of through volumes and left turn volumes, typically.
Yeah,
and
that's a big one. And
then whether you're in Synchro or Vistro or highway capacity software, whichever analysis tool you're using, it's pretty easy to zero out your left turns. And okay, zeroing out the left turns, hey, you're going to operate at level of service C. Okay, I'm on the right track. Well, how am I going to reroute those left turns is kind of the creative problem solving. So these 6 issues don't lead to a linear process, but it's looking at all of the issues that could be coming up, and as Brian mentioned, honing in on what is the problem you're trying to solve, then opens up the universe of alternative options to start analyzing.
Yep, and there are different states that have this process prescribed. MnDOT, obviously where we are, has their intersection control evaluation. And as you go through that process, they will start with essentially everything. We have an intersection. What could you put here? What could you do? And so you start working your way down. Doesn't meet warrants. So can you put a signal in? You could stop there. You could continue on, though, if you're trying to solve a particular problem, to say, okay, we need to solve this problem, which lends itself to these 3 types, and all these other ones can go away. So your first step is just trying to narrow yourself down from this whole universe into some that you think will work and will solve the problem. You do more analysis on those, and then you do some sort of matrix or some comparison between them, find your preferred. So again, it all starts with understanding the problems and then moving on to what will solve those problems.
So we've done a bunch of research, and there are a lot of interesting concepts out on the internet. I think that's true of any realm, but also true of
Yes.
traffic engineering. So we've boiled it down to kind of 10 intersection types that at least have been built. So they're not just concepts. There are about 40 concepts we found out there in the universe, but we're narrowing in on the ones that have at least been built
Yes.
to share with you. And again, we have a half an hour, so we're just mostly making you aware of these intersection types and kind of high level when you'd apply them. But each one of the intersection types could be its own hour-long
Very
case study.
easily. Very easily.
So with that, first one is, maybe Bryant and I were debating this, is it even an alternative intersection at this point? A roundabout. When we started our career,
Definitely.
they were definitely alternative intersections. And in some part of the country, they are very standard and actually the preferred. You start with a roundabout and prove why you need a signal instead of starting with a signal and proving why you need a roundabout.
Mm-hmm.
But there are other parts of the country where roundabouts are considered very alternative.
Yes.
Yeah.
You will get burned at the stake if you suggest it. So
Yeah. So we're putting it on here as our first alternative intersection. Kind of the pros of roundabouts are, the safety statistics are quite impressive, making intersections safer. Also, off-peak capacity operations is much better than a signal. With heavy enough traffic, they can break down, and when they break down catastrophically. So that's definitely one of the bigger knocks against them. And obviously, as we can look at this picture, a big issue is the right-of-way footprint. That works great out here in flat topography, out in the suburbs or out in rural areas. You're not going to put a roundabout in Manhattan. Just, there's not room.
So Tony just made a mention that he noticed on your photo here that we do have a yield sign that's on the left rather than on the right.
So looking at those two, we actually have two yield signs. We have them on both sides. So that gets into the design of the roundabout itself. They also have the text in this one.
We're not getting into the specific design of
Yeah.
roundabouts. This is just a nice, pretty picture of a roundabout.
Other than I will add that if you are looking at a roundabout, particularly the first one in a community, you want to make sure it works. These are valuable tools. They are proven tools for safety. Make sure that first one is successful, which might mean starting with a single lane roundabout rather than going to your dual lane right away. Let people get used to them and then move on to the more complicated ones.
Yeah, and with that, go overboard on the signing and striping. Of course, you don't want the left side yield sign to block sight distance, but assuming it's not blocking sight distance, yes, we normally wouldn't put them on a roundabout, but if it's the first 2-lane roundabout in an area, you may want to just, as a little increment to help sure it's going to operate better.
Yeah, and you could actually say that for any of these, if these are the first one in your area, plan on going overboard. Have an education, promotion to talk about it. Think of ways to get people involved and let them understand what you're trying to put together and how to operate through it.
Okay. So the next, number 2, again, this isn't cutting edge, but it is something that's practiced more in some parts of the country than others, is just access management. And typically we're talking a 3/4 intersection like this one, where you can't go north-south across on the minor leg, or it could just be a right in, right out intersection. Both of these, you're taking some left turn movements out of an intersection, and that can be beneficial. That obviously can be hugely beneficial for capacity and safety, but you have to figure out the alternatives. How are these people moving around the transportation network if you block certain movements that way?
Yep. And the reason to do this is you take those side street left turns out. That's the biggest bump in safety. So this is a safety component of it. Obviously, like Mike just said, though, there's still people who want to make that move. So where do they go? And that's the key thing for access management. It's just making sure that people can still get where they want. Incidentally, this pairs nicely with a roundabout. So if you put a roundabout at the major intersection at the next block, you can add this access management, and people can use the roundabout to make U-turns very easily.
So our third intersection type is the offset T intersection. And so you can imagine you started with a squared up intersection and pulled those side streets apart, making two intersections, which could have capacity issues, but you're making it easier on those main line volumes. They're not dealing with as much crossing traffic. So it's better from that standpoint. And the right turns also have less conflict. So this kind of intersection, you can avoid needing a traffic signal and operate it just with minor street stop signs.
And that'd be the key reason to consider it, is for some reason you don't want the traffic signal there, separate them. Typically, it should be easier for those side street movements. They don't have to deal with traffic from the opposite side, so they can potentially turn easier, make that movement. Just be careful on this one. If you have a lot of through movement where you're going from one side street to the other, you're creating a lot of overlap there. So it's just obviously something to evaluate as you go through your capacity issues. Again, what's the problem you're trying to solve, and does this solve it? The next one we have, indirect lefts. So using our little pen here, looks very traditional here, but what you can see then, this east-west line, there are no left turn lanes. And so for anyone who wants to, if you're heading west and you want to take that left here, instead of going at this main intersection, you're going to pass through, go beyond it, and then take a U-turn, come back, and then take a right. You can see it's the same going the opposite direction. Go past the intersection, do a U-turn, and come back.
And you'll notice at the U-turn intersections, they've bumped out and even made it so semi-trailers could make that U-turn to be able to come back. So that's a key design feature. And by eliminating the left turn phasing at the main intersection, you can allow the intersection to operate more effectively.
Mm-hmm. And this could be done, it could be based on the amount of through traffic. You're trying to preserve green time for them, get them through faster. Could be based on the volumes of lefts. Maybe you're trying to, you can't devote enough time to that, so you're trying to give them another option through.
Key with when you're analyzing an intersection like this, and the software tools, especially Vistra, are getting better at it, but really you're setting this, you're going from a single intersection with your delay, and now you're going to 3 intersections. So a more proper way to get apples to apples analysis is to do a micro simulation. So you're keeping track of the travel time, having to go down to a whole nother intersection and make a U-turn back. That it's a little bit more convoluted to get your alternatives to line up. So you're not discounting that delay time you're adding by forcing people to travel further.
Yeah, and the simulation is because there's travel time in there too. So it's not just the delay at each of the intersections, there's also some travel time between them. Number 5 is a split intersection. Could be called a jug handle. We've got a couple different ways, but essentially you're taking a portion of the traffic, again, off the main line, having them almost like an interchange where they're exiting off to the side, and then at this point they would have the choice to turn left and go back through the intersection or continue right. The option is the loop. Again, getting very close to an interchange where you come through, loop around, and then head back. The main purpose here is, again, to get rid of the left turns at your main intersection.
And the next intersection, continuous flow, and these have a couple of different names, and this gets pretty intricate of pulling people out before the pulling those left turns out before the intersection. So they're going westbound and then crossing over at an intersection beforehand. and then lining them up with the opposing right turn lane to force the lefts outside of the main intersection. This is a big intersection and obviously intricate to model it and to figure out if it's going to work and if it will have the benefit you're hoping it will.
Yeah, this one has a very big footprint. It is a more complicated in terms of operations. I have not driven through one of these, so I often wonder if I'm coming the opposite direction, I'm now splitting traffic. I have traffic going the opposite way on both sides of me. Does that impact how people drive? I think there's at least some questions about it. I don't know that would discount it if this becomes the tool to fix your issue, though.
And I think that brings up a really important point and a really fundamental precept of traffic engineering is we want uniformity across the country, across the world, so drivers know what to expect when they come upon a scenario. So their brain doesn't have to decipher a purple triangle as a stop sign. Just
Right.
We give them uniformity so they know how to behave. You will lose the kind of the friction of, if I was new to this intersection, it would be difficult for me to drive through it. If you're in a very heavy commuter corridor, then that friction kind of, as people get used to it, that goes away. But that's a concern of mine with any of these alternative intersections is people getting used to them. And we've seen that over the last 20 years with roundabouts even. So it does take time to acclimate.
Number 7 is an echelon, which essentially you're taking your intersection, you're splitting it into 2 and creating one-way pairs that then turn. So you can go with simple 2-phase operation. And if we look at this top level up here, so they're split up. They can now easily take that left. They can go through. If they were going, trying to think, if they were going the opposite way, they have to cross underneath. All right, I'm even getting confused on this one.
Yeah, if they're taking the right turn, they stay down at grade and are able to make that right turn underneath.
Yes, that's the one I was missing.
We're putting a bridge deck on top of the intersection. We're kind of creating an interchange without the freeway to split this into kind of the 2 one-way pairs that Bryant discussed. But obviously, this is wildly expensive.
Yes,
because you're introducing a bridge, and that leads to the next concept, which is, and you can do this with really any of these alternatives, but a way to reduce that cost and reduce the bridge deck height is to have those tunnels or the area the approach is going under the bridge deck to be for cars only. And they're doing this in Malaysia right now. I think it is just opening, but they've designed this, whether you want to call it an echelon or a hamburger interchange, what we'll be talking about. But the tunnels that go through this big circle are for cars only. So it's full movement for heavy vehicles on top.
on the roundabout, essentially.
Yep. But then the tunnels going for the cars only to shortcut. And that pulls, in most cases, 95% of the through traffic are passenger vehicles. And if you have the height restricted to kind of that 5 feet height, 6 feet height, instead of having to put in your 10 plus height to account for a semi truck, and you take that approach grade out, it cuts the approach grade down tremendously, obviously, and then that saves costs.
Now, this looks like it does require a large footprint, a large space to actually implement.
Yes, and for this intersection, it does.
This one.
This concept could be added even on a normal county road corridor. If we combined it more with the Echelon intersection, that we add a tunnel going through an intersection just for cars, we could take a lot of the through traffic out on a mainline county road and then leave all the turning movements at grade. I blogged about this a little bit a couple of years ago, and it's a very interesting concept. And of course, again, you would have to have the right traffic volume mix at the intersection to make it worthwhile. But if you had a corridor with very heavy through traffic, this could be a way to keep the intersections skinnier and pull out the through traffic that would have zero delay going
Yeah,
through.
it works by looking at your fleet of vehicles and going to the smallest one rather than designing for the largest.
And obviously the elephant in the room is making sure that semi trucks can't get into that lane and then smash into the top of your tunnel and all of the issues around that.
Yep.
Well, we do have a couple of our attendees today that have mentioned that Tony had said he's been helped develop one that was in Lafayette, and there's also one of these echelons in Southern Florida. So examples, and
Do we have the actual intersection locations?
that
In the
request
chat?
has gone out, so we're
Okay.
sorry we can't get that.
Okay, while we're waiting for that, we'll move on to the next one that we mentioned, a Hamburger Intersection.
My favorite name
Yes.
of all of these.
This one I have actually looked at before, at least studied, tried to put it in, was not successful in that, but it's essentially the roundabout, and you take the through traffic on the main line and bring them through the center. So it's a signalized roundabout where either the through traffic is going or they're signalized on the stop and then the side streets go. So it's in almost a two-phase movement. Your through traffic goes on the main line and then it stops, and then the side street and the other movements all go in the roundabout.
Yeah, also called the throughable. So interesting concept. This one is in Fairfax, Virginia, I believe. So they are on the ground. And we think it's an interesting concept that could have more application.
Mm-hmm. All right, last one, our number 10 for this list is the double crossover intersection. So distinct from the interchange, but with similar elements.
Yeah.
So
the DDI interchange, the diverging diamond interchange, similar in
double crossover interchange. It's also
similar in concept, but
Yep, and the idea is, again, moving from east to west, you're coming along, you are shifted to the other side where that is an easy left turn movement. And then on the other side of the intersection, you are shifted over to back to the correct side for driving. So you still have conflicts on the side street, you still have that overlapping traffic, but your right turns are close to the curb movement, very easy to do. Your left turns do not have to worry about the opposing through traffic, so you are removing a lot of conflicts from it. And again, you're simplifying at least the movement, simplifying the conflicts, which should allow you to put more traffic through the intersection.
yeah. So a couple of my favorite resources when doing research for putting this presentation together. FHWA has a good website there, and also the Center for Transportation Studies in Maryland as part of the Maryland DOT ATAP Center. If you dig around there, they have a good website that actually has intersections listed for the different types, and they also go into interchanges as well as at-grade intersections. So starting with the Maryland DOT, I think that's where I would start looking. But both places are great resources. If kind of that once every couple of years you run into just almost an unsolvable problem with our normal intersection design, to start thinking creatively and get your creative juices flowing about what kind of options are out there.
It looks like we have a little bit of time. Would you mind going back to your number 3 option? I believe that was an offset T that we were talking about.
Before you ask the question, I will say we are coming up on 1 o'clock here. So just very quickly, I'll say thanks for everybody who joined us. We're happy to stay on the line for any questions. So we'll stay through whatever questions are there. Just if people need to drop off at 1, thanks for being with us. We hope to see you next month as well.
And also for those people who are in attendance today, we will be sending out a link to the replay of today's session. Look for that to appear in your email box tomorrow. I just wanted to make a comment here. Philip, who's on the line with us today, he just made a comment that in this particular intersection, that it has a lot of left entries, and that's a potential safety issue unless a freeway design is set up for a left entry and an acceleration lane and merge lane. And I'm wondering if there's any thought on that regarding this particular intersection.
Well, I don't think you'd be using this for high volume intersections. I think if you have a high volume, you're going to be going towards a signal or something else. So I would more envision this. The signals are off to either side, and there may be a reason why you don't want a four-legged signal in between them, but you don't have enough capacity as just a side street stop. So if you can split them, now you can allow that traffic to get out a little easier. But again, my view on it is we're not talking about high volume intersections in this case.
And to piggyback on that, I agree. Yes, the more lefts we have, the bigger safety issues, and that is directly proportional also to the speed limit on the road, or the 85th percentile speed of. I would be a lot more hesitant to put in this design on a 55-mile-an-hour county road corridor than I would if this was kind of a local minor arterial or even a collector intersection more at the 30-mile-an-hour speed. So valid points. And yes, that'd be part of the design analysis.
In case you are on the line but haven't been watching chat, I just wanted to point out, John mentioned that the Virginia Department of Transportation also has an interesting website that discusses some alternative intersection designs. He did provide the link. Thank you, John. So if you are on our recording today, take a look at that link to the Virginia DOT for alternative intersections. Just looking to see if there are any other questions for our presenters today. We're wrapping up on our time here, but we do want to make sure that we answer any questions. Sam, thank you for pointing out that you do have a video of a double crossover in Calgary. We'll take a look at that as well after this, but thank you so much for sharing. All right.
Okay, last, we'll point out that we've been undertaking a stop sign research project of trying to figure out compliance rates with unwarranted stop signs, and we're working with a lot of cities around the country. We'll be doing a phase 2 even. We have so much interest, but we're going to be sharing our initial results coming up here next month, and we expect that to kind of be a hot topic kind of in our research, under-researched area of our profession.
Yes.
Stop signs are not magic bullets, and now we have data to help figure out when and when not are good applications.
I do have one other question for our presenters. Neil asks, what are your thoughts on the CapEx software from the Federal Highway Administration?
To be honest, I haven't used that one much. I thought they just came out with a new version of it too, not too long ago. But I haven't, just I'll flat out say I haven't used it much, so I can't comment on it specifically.
Yeah,
for this.
No, I haven't used it either. Do you have an initial opinion on it? It'd be great to share with the audience.
Yeah, Neil, feel free to put in your thoughts if you've used the software. Going back, number 3 design has one more comment from Arturo. It says in the number 3 intersection, can we use a modification putting an acceleration lane with a merge lane for the left turns?
Yes. Yeah, absolutely. And that's kind of the mixing and matching between these. And I think that underscores an important point with this is these concepts can be mixed and matched in many different ways. You're just trying to creatively problem solve to a good solution. So adding in acceleration lanes, that could go in several of these different options that could help improve the operations. So a very valid point.
For that offset T in particular, obviously you need to understand your turning movements. If everybody, we talked about, you don't want to have a lot of through movements between the 2 side streets, because if that's the case, you have weaving there and an acceleration lane does nothing. So
yes, except make the intersection maybe wider, which could
lead
pose
to more
safety
problems. Now
Yes.
they're weaving over a greater distance. So again, trying to understand, like we said the whole time, what's your base issue? What are you trying to solve? and how does a particular intersection design help you solve that issue?
And do you feel that that's the same case in the access management example that you had? That was number 2.
That
Acceleration lanes can be great for that. And access management can be a reason, or the speed on the road can be a reason for the access management if there's a safety issue for it. So absolutely, I think they can be looked at. Like Mike said, a lot of these, you can look for specific designs to help them operate better. So.
And the acceleration lanes, his typical is more so on the kind of the curb side, the outer side of the intersection, but we did a big study with MnDOT here this past year that you can find on Mike on Traffic about situations where they put acceleration lanes on the inside
for left turn movements,
for the left turn coming off the minor street to turn onto the highway, to provide them an acceleration lane. And we found very mixed results to little benefit with those acceleration lanes. So I think before you go down the path of thinking acceleration lanes are going to solve problems, you need to do the research on them and figure out, in your situation, does the analysis back up your hunch that they're going to be beneficial?
Yep.
Okay. Well, that's all the questions that I can see at the moment. I want to thank everybody for joining us at today's session. Again, look for a copy of our recording to come out tomorrow. You'll find that in your email box. I want to thank everybody for joining us and thank our presenters for their time today. If you do have any questions or have suggestions for future topics, feel free to email me. It's ncrow@spacconsulting.com. We hope you can join us for April's session.
Thanks, everyone.
All right. Thank you.